Professor Clements with you as we consider Section 8 of Chapter 27 of OpenStax College Physics, the topic of polarization of light. So in this particular problem, let's say we have 80 units of intensity, just arbitrary, 80 units of intensity that's going to pass through one Polaroid filter. This light is unpolarized. Another way to state that is that there's no one direction of vibration or oscillation of the electric and magnetic field. Instead, we have random orientation. So as the light passes through a single Polaroid, if we have 80 units coming in, we have these long molecules in the Polaroid material. The electric field in the same direction as these long molecules will move electrons along them, will do work on these electrons. That takes energy away from the electric field in this direction. So we end up with polarized light, the vibration perpendicular to long molecules coming out, and half of the intensity when we go through one Polaroid. So we'll have 40 units of intensity surviving, coming through a single Polaroid. We start with 80, 50% gets through one Polaroid. That's the result. So let's bring in another Polaroid, and we've got 80 units again coming into the first Polaroid. We've got 40 units exiting, and now we have a second Polaroid. It's kind of face on to the first Polaroid. My drawing here, has room for improvement, but this second Polaroid, the long molecules are tilted 28 degrees to the long molecules of the first Polaroid. And I should make a comment here about this statement, polarization axis. The polarization axis is actually perpendicular to long molecules. So this would be the polarization axis. That's where the light gets through. The oscillation of the electric field is along that polarization axis. So here's our polarization axis for this first Polaroid. I'm going to attempt to draw in this next Polaroid. Here are the long molecules, and here is the polarization direction, trying to go 28 degrees of rotation here. And what will be the intensity of the light that comes out of this Polaroid that's swiveled around a little bit? Well, to calculate the intensity when we're sending polarized light into another Polaroid, we use this calculation. The intensity that comes out is equal to the intensity that's coming into that Polaroid, I naught, times cosine of theta squared. Theta is the angle between the two Polaroid axes, polarization axes. And it's important to note here in the meaning here, you first must take cosine of the angle and then square that result. So we have 40 for the units of intensity coming in, and I'm going to kind of expand this out a little bit. I'd have cosine of 28 degrees, and then the meaning of putting the square here is that you must not square the angle first and then take cosine. You must take the cosine of the angle first and then square that result. So try this on your own calculator. The cosine of 28 degrees, I came up with 0.8829 and some other digits I won't copy down here. I have to square that number and then multiply by 40. I came up with 31.2 units of intensity, and that's reasonable in the fact that it's less than 40. And 40 units coming in, we lose some more energy. There's some component of this horizontal oscillating electric field that's doing work on electrons here. So just 31.2 units. And now, more fun. We have a third Polaroid, 42 degrees tilt compared to the last Polaroid we used in Part B. So my drawing just gets more complicated. 80 units coming into the first Polaroid, 40 units coming out. We had 28 degrees tilt here, We just found 31.2 units coming out of that, and now we're rotating around some more, 42 degrees. So we are going through the material, but it's rotated around 42 degrees. How do you think we'll calculate the intensity coming out of this last Polaroid? And again, I'll put on the polarization axes. This is a rotation of 28 degrees with respect to the first Polaroid. Here's a rotation axis here, and what it should be is 42 degrees rotated compared to this middle Polaroid. How much intensity do I have coming out? Well, now our I naught is the intensity coming in here, 31.2. Again, cosine squared. I have to use the 42 degrees of rotation of this last Polaroid. Again, 31.2, take cosine of 42 and square that number. So if we do that, 31.2, and I have 0.7431 that has to be squared, and I ended up with 17.2 units. Again, reasonable in the fact that 17.2 is smaller than 31.2. We're blocking some more of the light. So fairly simple calculation, doing the very first Polaroid here, unpolarized light going through a single Polaroid, half of the light goes through. We have 40 units of intensity when we started with 80. When we have a Polaroid processing light that is polarized, then we have to do the calculation that involves cosine squared of the angle of rotation between these two Polaroids. So keep practicing with that, and ask your instructor questions. Replay this video if necessary.